Hello, today we are going to talk about general system theory. The general system theory was proposed in 1936 by the biologist Ludwig von Bernstein. He emphasized that real systems are open, that's a really important characteristic about systems, and interact with their environments. Then, the system theory focused on the arrangement of a relation between parts. That's another aspect that is really important in general system theory. Always exists a relationship between the parts, interaction between the parts. And now that part connects to create the whole. Then the whole is composed by parts, and we have to analyze the parts in order to understand the whole. If we use the general system theory in math, we have one specific application, and that application is the equations. Then let's consider this equation. Equation 2x plus 4 equals to 8. Okay? Then this equation has parts. Then we have the left part, 2x plus 4, and we have the right part, 8. But the left part is composed by parts too. 2x is this part, and 4 is another part, another term. The right part is composed just by one term. The term is 8. Now, the terms also are composed by part, or can be composed by parts. For example, the first term, 2x, is composed by 2, that is the coefficient, and x is the variable. The second term, 4, is the constant. Now, the right part, 8, is also a constant. Okay, this is the part of the equation, but this is not the only ones. Here we can identify another part. This is the symbol, or is the equal sign. Okay, it's a symbol, it's another part, important part. Without an equal in this expression, then it is not an equation. Without equal sign or equal symbol, don't exist any equation. Now, another one, the operator, that in this case is plus, is also important. Okay, then this is the other part of the equations. All of them, they are in an interaction in order to analyze and create the whole equation. Now, let me show you another example. Let's consider now this other equation. Equation y is equals to 2x plus 4. Okay, in here we have an equation with two variables. X is a variable, y is a variable. If we have two variables in one system or in one equation like here, one variable must be the independent and the other one must be the dependent variable. Okay, in here it's really simple to identify because the isolate one, in this case y is the isolate one, is the dependent variable, and x, that is not the isolate one, is the independent variable. Okay, then for example, let's consider this case. What happened in this equation if x is equals to 3? If x is equals to 3, then we have to replace x value in the equation. Then y is going to be equals to 2x, 2 times x, but x is 3, then let's replace 3. Then this x is 3. Then we are replacing just x by 3 because it's the x value, plus 4 according to the original equation. Now let's solve the operations. Then y is going to be equals to, in here we have two operations, multiplication 2 times 3 and addition plus 4. Obviously we know that multiplication is first, then 2 times 3 is 6, and then we have to solve the addition. Then y is going to be equals to 6 plus 4 is 10. Then we have the independent variable x and the dependent variable y. X is independent because you, as a searcher, you can, or as a researcher, you can provide the value for X, and depend of X value, you can have a special value for Y. Then, in other words, we can say that X is the input because we provide the value. We have the X value and we put in the equation, and then we have an output. In this case, the output is Y, because depending of the input X value, we have a special Y value. Now, let's analyze exactly the same equation but in a context. Okay? Then let's suppose that we are talking about temperatures, and let's suppose that there is a relationship between Bogota's temperatures and Ottawa's temperatures. Ottawa city in Canada, capital city in Canada. Okay? Let's suppose that exists a relation between Bogota's temperature and Ottawa's temperature. Okay? And let's suppose that the relation is this one. Let's suppose that the temperature in Bogota is always twice the temperature in Ottawa, increased by 5 degrees. Okay? This word problem that I'm proposing can be modeled in an equation. Then Y represents Bogota's temperature. Okay? Is equals, remember the word problem. The problem says that Bogota's temperature is always twice Ottawa's temperature. Then we have two variables, Bogota's temperature and Ottawa's temperature. Then Y represents Bogota's temperature. Is equals twice. Twice means times 2. Times 2 what? Times 2, or the double, or twice the Ottawa's temperature. That's the other variable, X. But increase means plus, increase by 8 degrees. Okay? Then this equation, Y equals 2x plus 8, is the model to represent that relationship. Then remember, Y is Bogota's temperature, X is Ottawa's temperature, and increased by 8. Okay? Now, if we consider or we analyze in this situation, then depend of the Ottawa's temperature, we can calculate Bogota's temperature too. Then Y, Bogota's temperature, is going to be the dependent variable, and X, Ottawa's temperature, is going to be the independent variable. Then let's analyze. Let me erase this information in order to analyze one specific case. Okay, then let's analyze this case. What happens if in Ottawa the temperature is 7 degrees? Okay, then let's do it. Then Bogota's temperature is equals twice Ottawa's temperature, that in this case is 7 degrees, increased by 8 degrees. Then Bogota's temperature is equals to 2 times 7 is 14 plus 8, because remember that the word problem said that it's increased by 8 degrees, and Y, Bogota's temperature, is equals to 14 times 8, that in this case is 22. Then when in Ottawa the temperature is 7 degrees, in Bogota the temperature is 22 degrees. Simple. Now, obviously we can analyze more cases. What happened if in Ottawa the temperature is -1 degrees? Then we have to replace by X by -1 and solve the operation. Okay, then let's analyze. Let's do that operation one more time, that exercise one more time. Okay, let's suppose that relationship is exactly the same. Then Ottawa's temperature is -1. Then Bogota's temperature is equals to twice times Ottawa's temperature, in this case is -1, increased by 5. Okay, then Bogota's temperature is equals to 2 times -1 is -2 plus 8. then Bogota's temperature is equals to 6, because -2 plus 8 is positive 6. Okay, remember the input, Ottawa's temperature, the output, Bogota's temperature. Guys, this is a really nice example about general system theory application in math. Thank you so much.